Welcome to Lab 1, Charged Tape. The purpose of this lab is to become familiar with charge using everyday objects and the interaction of charged objects. The problem is how much excess charge is on the piece of clear tape. We'll use Coulomb's law, which relates electric field, forces, and charges to examine the physical effects of charge. And we will make a computational model to visualize the effects of charged objects. And the result that we found was that the charge of the tape was minus 1.27 times 10 to the negative 8 coulombs. And the charge is negative, meaning that the tape had an excess of electrons. In this experiment, we first create a piece of charged tape by quickly pulling off a piece of tape off the base tape. Then we test if the charge is positive or negative by rubbing a plastic pen and observing the attractive or repulsive reaction. In this case, the plastic pen is negatively charged, and since the tape was repulsed, the tape is also negatively charged. Then, with two or more pieces of charged tape, we lift one piece of tape below the other, as shown by the diagram, until the top piece is floating, and then we measure the distance at which it started to float. The assumptions we need to make the models in this lab are that the tapes are treated as point charges, and the tapes hold the same net charge. In the physical model, as seen by the free body diagram, the tapes repel each other as they're both negatively charged. Further, the repulsion forces are of equal magnitudes but opposite direction. And then because the top tape B floats when there is no net Y force, that means that the electric force from the bottom tape A has to counteract gravity. In this experiment, we measured the tape length to be 0.22 meters, the tape width to be 0.0225 meters, and the distance between the top and bottom tapes was measured to be 0.023 meters. Using these values, we also calculated the force of gravity, or weight of the tape, surface area, as well as the number of atoms on the tape, as you can see below. Now to find the electric force on B by A, we know that the electric force will be equal to the negative gravitational force, giving us the vector 0, 2.16 times 10 to the negative 3, 0 newtons. Now we can use Coulomb's law to find the approximate charge of the tape to be negative 1.32 times 10 to the negative 8 coulombs, where the charge is negative because the negative plastic pen repelled the tape. Then, to find the total number of excess electrons, we can take the charge of the tape we found and divide by the charge of an electron to find that we have 8.27 times 10 to the 10th electrons. Finally, we calculate the fraction of atoms that gave up electrons. We find the total number of atoms, then we find the ratio of excess electrons to atoms through division. Here we make a computer model reflecting the physical model using GlowScript. We first define the constants and then use code to compute the results as shown. Check the description for more details. As seen by the 3D model created from GlowScript, we see that the model reflects what we predicted in the physical model. To address the first reflection question, if the signs of electrons and protons were reversed, what would change? The answer is that the tapes would still repel each other because of their like charges, and opposite charged objects would still attract each other. So the interactions of objects wouldn't change much. The second question is, why is it important to handle the tapes as little as possible? Well, this is because when the tape that has excess electrons interacts with other objects, specifically other neutral objects, the electrons will transfer to the more neutral object, and the tape will lose charge. Thank you for watching. See you next time.